Let's try another related rates problem. This one does not have a picture, so first we're going to start by drawing a picture as we go. So number 3, a policeman traveling south towards an intersection. So let's say we have police car here, police car. He is traveling south towards an intersection right here. Here's my intersection. There we go, intersection. And he spots a speeding car traveling east away from the intersection. So here's my speeding car. He is traveling east away from the intersection. North, east, south, west. Never eat soggy waffles. When the policeman is 0.6 miles from the intersection, so we've got 0.6 miles from the intersection, and the car is 0.8 miles from the intersection. Actually, I think I want to write this on the outside so I have more room. The policeman's radar shows the distance between them is increasing at a rate, which should immediately tell you derivative, of 20 miles per hour. If the speed of the police car is 60 miles per hour, what is the speed of the car? Now, let's start by giving this some letters. So let's say this is A, this is B, and this one would be dc dt, because it's a rate. And we're taking it with respect to time. We also know that dA dt is 60. Now, one thing we want to be really careful of. If I think of this, here, let's do it solid. If I think of this as a coordinate axis, notice that the police car is traveling in the negative direction. The speeding car is traveling in the positive direction. Now, we don't need to make A negative because that's a distance. It's the distance between them. But the rate that he's moving, he is moving in the negative direction. So we need to make sure that that number is negative. Okay, let's list given, implied, and find. So it's given that A equals 0.6 miles. It's given that dA dt is negative 60 miles per hour. It's given that B is 0.8 miles and that dc dt is 20 miles per hour. We want to find the speed of the car, so that's going to be dB dt. Now let's think implied. First off, I have A, I have B. Is there any way we can find C? Once again, using Pythagorean's theorem. So I would have 0.6 squared plus 0.8 squared equals C squared, which 0.6 squared plus 0.8 squared is C. Sorry, is 1. That's what I meant to say. So C is going to be technically plus or minus 1, but it's a distance, and we don't really do negative distance, so 1. So it's implied that C equals 1 mile. Exactly. Okay. Next, we need an equation that relates all the variables that we'll take the derivative of. Once again, the equation that's going to relate all these variables is Pythagorean's theorem. That's a really easy equation that matches this picture, have that right angle, and uses all the variables we have. So let's take the derivative of this, 2a, and then the derivative of a with respect to t, plus 2b, the derivative of b with respect to t, and 2c, the derivative of c with respect to t. Plug in what we know. 2a is 0.6, dA dt is negative 60, plus 2b is 0.8, dB dt is what I don't know, and 2c is 1, dC dt is 20. So if I simplify all that down, I'm going to get negative 72 plus 1.6 dB dt equals 40. So let's add 72. Get 1.6 dB dt equals 112. And then divide by 1.6. So dB dt is going to equal 70 units miles per hour. And because this is a story problem, we need a sentence. So what is the speed of the car? The car is going 70 miles per hour when, just like last time, this is a specific point in time. The car could be going 65 miles per hour in 30 seconds. We don't know. So we're saying the car is going 70 miles per hour when it is 0.8 miles from the intersection. You could also say when it's a mile from the police car. When the police car is going 60 miles per hour towards the intersection. Something like that. Okay, there's that one. In the next video, we'll do the last related rates problem. You got this, guys.